Hey guys, Dan the Mustang Doctor here, and I'm here tonight with one of my patients, Shelby, and we had to get Shelby on the dyno and essentially just check her power at the wheels, torque at the wheels. And I'm here today because I wanted to share with you guys or kind of talk through how you data log, what a data log is, how it correlates to dyno testing, how it correlates to tuning and future tuning, and just kind of give you guys a run through on that. So what I've got up here today is a data log from the dyno run. And essentially what a data log is it's basically a recording of what the computer's doing in the car when you record it, when you record a data log. So in this case, it was during a dyno run, and it's got all kinds of parameters in here. We use LiveLink, which is an SET program. We use our SET4 X4 tuner, which is really where you take the tune file from the computer to the car, and it's also where you take the data log from the car to the computer. So to tune, we use Advantage 3, which is a Pro Racer package through SET. And but today we're going to be looking at a little bit of the tune, but mostly the data log itself through LiveLink. And so here you can see this is the data log. So we had recorded this when we did the dyno runs. And down here are some of the key metrics that I want to look at and talk to you guys about as we run through this data log. But it's interpolating a lot of other data and putting it all in the same graph essentially. So some of it is important, some of it's not. It depends on what you're looking at and what you're doing. For us, we're looking to tune for performance. So right now, just going to kind of take a look at these that we can see really well. You can click on each one and highlight it, and it shows in the different color what we're looking at, which here is AFR, or air to fuel ratio. But I'm going to keep it on RPM, which is this line right in here, and you can see where it jumps up as we get into the dyno run. And essentially what we're going to start and play it. I'm just going to hit play, and we'll talk through it as it plays out. So I'm going to start right there. So basically what's happening right here is you can see our RPMs are quite low, 2,300. They're going to climb right into the RPM range once we get under wide open throttle and we're into the full dyno run. But right here we're going from first gear to fourth. And we want to get into fourth for a dyno run because fourth gear in a car is 1-to-1. It's a 1-to-1 ratio between the transmission and the engine. And that's where you're going to get the most accurate reading on the dyno. So right now we're just getting it into fourth gear on the dyno. Once we're in, you'll see us jump on the throttle, which is really considered wide open throttle, or WOT. And that's where the car is just starting to accelerate all the way through fourth gear, through the RPM range. One of the things you guys are going to notice about this car in particular is these RPMs are going to climb quite high, much higher than most cars. It actually redlines at 8,250 RPMs, which is really crazy when you think about it. Most cars usually redline around 5,000, 6,000. But that's because this engine's a flat plane crank, so it can handle a lot more RPM, and a lot of the components in it are also forged, so they can handle a lot more power and a lot more RPM. So right in here, as we really jump into wide open throttle, it's going to come in right above 4,000 RPMs, and that's where we're really going to step through the RPM range. And when we do that, take a look at the spark advance or timing, and watch what happens there, as well as the air to fuel. And actually, let's just jump back for a second because I think we're already into wide open throttle there. I can see it in the AFR. So let's stop that for a second, jump back for a split second here, right here. And we'll start right here. You can see the AFR is right at 14, which is really a stoic AFR, which is really a perfect air to fuel ratio. But once we get into the throttle, it's going to drop down quite a bit. And that basically what that's doing is richening up the fuel ratio. And the car needs more fuel when it gets under load like that. And you can see it just drop down right there to 12, 11, which is a really good, really rich air to fuel, but it's dead on where you'd want to be on under wide open throttle. You also might have noticed that the spark advance or the timing dropped down a little bit. And basically what's happening is you want to be advanced because basically what happens in the piston stroke is the spark plug, the fuel comes into the piston, the spark plug ignites, and that creates a combustion which drives down the piston, turns the crankshaft, turns the drive shaft, and then turns the wheels. Well, what you want is you want to be a little advanced on that spark timing. We can see it's dropping down a little bit further even as well. It's retarding a little bit more. You want to be pretty advanced. You can't be too advanced. So basically what advanced means is that spark is coming in earlier than top dead center in the engine. And you want it to do that because that's going to stay out in front of the combustion stroke, keep things moving faster and faster and faster. There is a point where you can get too far advanced though, where you're kind of tripping, the engine's tripping over itself and it's detonating, they call it. And that's basically where the timing is so advanced that it's igniting the fuel, the spark plug's igniting the fuel, but it's doing it too far early from top dead center in the piston stroke. And so basically the piston's fighting the pressure, it's fighting itself. And therefore you're not getting more power out of that, and you're also going to be getting engine knock, which you don't want. So you can be too far advanced, and one of the things we'll look at when we data log is the knock to ensure there isn't any detonation or knock. We had looked at that already, and we knew there wasn't because this was a stock spark table. But one thing we do notice is it's pulling quite a bit of timing, or retarding the timing, they call it. And what that is it's either the current timing table that's set up in the tune, or it's a thing called torque management, which some of these new cars have now. So what we're going to do in the tune is we're going to go back in and we're going to look at the timing table, or the spark advance table, and make sure that that table is structured the way we want it for the right amount of spark. To get the most power out of this car, we probably want our timing or our spark advance closer to 23 at this point under wide open throttle. And it's not. We saw it at 18 before. I think we even saw a 16 number at some point. So we don't know if that's the timing table because we haven't looked at it in the tune yet, or is it the torque management table? And I'll take a quick second just to kind of talk to you guys about torque management and what that means. Basically what that is the car has 28 different torque tables set up. And these torque tables are designed basically to keep the car safe from breaking anything like a rear end or a transmission or an axle for that matter. But what it does is it keeps it a little bit too safe for cars like this. And most cars back in the day didn't even have any torque management. So whatever the car was putting out for torque is what that car was getting at the wheels. And essentially what the torque management does is it senses the amount of Newton meters of torque coming through at different RPM and load ranges, which I'll show you guys in a second. And it starts to retard timing as needed to keep the torque down if it starts to sense too much. You don't want that in a car like this. So essentially what we're going to look at, I'm going to show you guys a torque table right here. This is actually a stock 1 torque table on this car. And you can see it right here. This car actually made tonight on the dyno 504 rear wheel torque, which is quite a bit. It's quite a bit more than that. So this is basically the torque management table saying, down in this range in here, we want to keep the car a little bit safer and keep the components lasting a little bit longer. So we're not even getting into the car's real potential until we're almost under wide open throttle completely, and we're above 3,000 RPMs essentially. So down in here is where you kind of feel the car a little bit more sluggish because the torque management's kicking in and it's saying, hey, wait a minute, we don't like how much torque is coming out, so we're going to retard the timing a little bit and slow this car down a little bit. And that's what we saw in the data log when it was jumping around right in here. If you guys can see that, you can see the spark timing was at 18, and it really should be at 23, but this is that torque management table retarding the timing a little bit to try to keep things a little bit safer as we get up through the RPM range. So essentially what we're going to do is we're going to take a look at all of those torque tables. We're going to look at the timing table. We feel the air to fuel is really dialed in. If we do need to advance the timing more though from the timing table, or if timing just purely gets advanced because we reduce the torque tables, we may find that the air to fuel comes a little bit out of line. We might need to go back in and make some adjustments, but likely the car is going to be running in closed loop, so it's going to be taking sensors from the O2 sensors, sending it back to the computer, and then making fuel trim adjustments for us. So we don't think that the air to fuel is really going to come out of line, even if we add a little bit more timing to the car. But we'll see. We'll do another data log when we get on the dyno again and just make sure. So a lot more to talk about in upcoming videos on data logging and dyno runs. we're gonna go in, we're gonna get some of the tuning done on this car. We'll get it back on the dyno, and we'll give you guys another video, and we'll go a little bit deeper into more of the data log and some of the other parameters like intake air temperature, how that can affect timing, and a whole host of other details. So have a great day, guys.